Look into my eyes and show me your...
Guys, in today's video, we're going to look at more exam-style questions for circle theorems. Okay, so this is actually part 2 of the video, okay, on Friday the 5th of June 2020. Right, guys, if you're new, welcome. My name's Abdallah W, and I'm a private maths tutor and a qualified maths teacher for secondary and primary. Don't forget to subscribe if you're new and drop the video a like and enable notifications by pressing the bell icon. But let's get on with today's video. Right, guys, we're going to look at 4 examples actually for today's video. Okay, just extra practice. Okay, and then at the end, I will pass you on actually to more videos actually that might be useful for circle theorems actually and other areas of maths. Right, guys. Okay, so example 1 actually. Okay, so we're looking at higher tier GCSE Edexcel AQA. Okay, so we're looking at grade 7 for the 9 to 1 curriculum actually for GCSE level maths. Okay, so, so example 1. So A is the centre, D and B are points in the circle. Find angle ACB. So ACB, so that angle there is 90 degrees. Okay, what is the name of the line DB? So that's a chord. Okay, so line DB is a chord. Okay, so remember guys that a chord is a diameter, but it doesn't go through the centre. So that's the key difference. Okay, work out angle ADC, that is 90 degrees. And the reason for that, guys, is from one of the circle theorem's rules, okay, that a chord, okay, is perpendicular to the radius. So the chord, so this line here is perpendicular to that line there. So therefore, all my angles here, so obviously all of angle C actually, it will be 90 degrees because it's perpendicular. So AP is perpendicular to DP. Okay, so that's the reason for that. Right, guys, example 2. Okay, so it says here, find angles ABD and ACD. Okay, so we've got 63 actually. Okay, so we've got ABCD actually. So they're points on the circle. D is a tangent. Okay, so D, sorry, not a P. Okay, so ABD. Okay, so we're going to work out ACD first actually, because then we can say, okay, so ACD is going to be 63 degrees because of the alternate segment theorem actually. So remember that rule, guys, alternate segment theorem. So that will give us that answer there. Okay, and then I can deduce that if that's 63 actually, then that has to be 63 actually by the other rule, which is angles in the same segment are equal. Okay, so that's going to be, so these two angles are the same, okay, for that other separate rule, for obviously circle theorems. Okay, part B, what is the line D called here, touching the circle? Okay, so I've put that in there, as just extra practice. Okay, so D is what I call a tangent. So a line that touches a point of a circle is what I call a tangent, guys. Okay, so it's what I call a tangent. Okay, so that's there actually. Okay, right. Example 3, guys. Okay, so so we've got RST actually, and then we've got it should be some letters here actually, but I've got the letter N here, M, okay, and then I've got letter L. So the question asks me, the exam question asks me, work out angle M, N, and L. Right, so the first rule, okay, so we were given 64 actually, we were not given 120 actually, but I will talk you through actually how I got my answer. So 123 actually, so angles at the centre here is double the angle in the circumference. Okay, so 64 times 2 gives me 128. Okay, and then I've got an isosceles triangle here. So that angle there and that angle there actually are going to be the same. So 180 minus 128 is going to give me 52. Divide that by 2, that will give me these two angles here. Okay, which is going to be 26. I can then deduce here that a tangent to a circle actually is perpendicular to the radius or diameter. Okay, so M plus 26 has to equal 90, and N plus 26 has to equal 90. So therefore, M and N obviously are going to be equal. So M and N are going to be equal to 64 degrees. Okay, so that works out M and N. Okay, and then I've got to work out what L is. To work out what L is, guys, angles in the triangle add up to 180. So 64 plus 64 is going to be 128. 128 plus 26. So L is going to be equal to 26 degrees, guys. Okay, So that is how I work at that one. So what I'll do, guys, sorry, I'll just zoom in actually so you can see a bit clear, okay? Because it might be hard to see actually. So that and that year were worked out because they were isosceles triangles. Okay, so 1, 2, 8 was there, 26, 26 actually. Okay, and then I said that n plus 20 because a tangent to a circle actually is perpendicular to the radius, so it has to give me 90. So that angle plus that angle has to give me 90. Okay, so that's how I worked out that one, guys. Yeah, so I hope it was clear. Okay, so yeah, I'm just zooming in for a few more seconds, so you can see. Okay, so that says 64 there. Sorry about my bad handwriting. Okay. Right, guys, last example. Okay, so it's just some quick questions. Okay, what's the difference here between a sector and an arc? So a sector, guys, a sector is a section inside the circle, okay? And an arc here is the part outside, actually. So a sector is the bit like inside, actually. So this is what I would call a sector inside, and the arc length here is just part of the circumference, okay? The reason I'll put that in there actually is because I've seen like a lot of exam questions here that look alike, yeah, like sectors and arcs and like segments. So it's important that we like distinguish like the definition between the two. And lastly, it says part B says what's the same about angles in a triangle and angles on a straight line? They both add up to 180. So angles in a triangle add up to 180. Angles on a straight line actually add up to 180. Okay, so that's the fundamental actually. Yeah, obviously yeah, part of this actually the same actually. So I'll put that in there just like mix up actually to like throw in some like random questions actually, yeah, like just obviously like yeah, test our understanding, yeah, for like circle theorems actually, yeah, as well as like that. Okay, right, guys, thank you for watching actually, yeah. Please do as ever subscribe, yeah, and drop the video a like actually, and comment below actually, yeah, and feel free to obviously share my videos around and let me know, yeah, of like any feedback actually, yeah, that you want me to improve on for like future videos. Okay, yeah, I would really appreciate that. Feel free, guys, yeah, to check out Maths Chelsea, Corbett Maths, Maths Genie, Hegarty Maths, TL Physics and Exam Solutions, and Khan Academy. Okay, so they're all really good like YouTube channels. Okay, thank you for watching, guys. Yeah, please stay safe, and I hope everyone's doing okay. Thank you for watching. Bye now.